So today I want to present the dreams alive, running Linux containers on an illumos kernel. And it's based on the idea of OS emulation, which is actually a very old idea. I don't actually know, unlike with hardware emulation, where I actually believe I know the first system that engaged in hardware emulation. I believe the first system is the Honeywell H200 emulating the IBM 1401. I actually don't know the first system to engage in OS emulation. It is almost certainly in the 60s. It is likely from IBM. It's certainly the 360. The 360 didn't follow on. Surely did. But the idea here, in terms of OS level, and what I mean by OS emulation, I mean that the abstraction that you're fooling the application with is not the hardware. With hardware virtualization, you present artificial hardware, and then on that artificial hardware, you drop an operating system, and then on that operating system, you drop an application. With OS emulation, the hardware is not the abstraction, the OS is the abstraction, and what you fool it with is a different system call table. Now the hardware is all going to be the same, which there's a kind of an important constraint. It kind of needs to be a binary for the same hardware. So it has to be, you have to have a binary that's effectively compiled for the same hardware. And then the degree that this is possible just depends on how different these two operating systems are from one another. Now, in some cases, actually, kind of an interesting argument or question to have is to what degree was VMware engaged in this? Because VMware actually, before they had hardware assist, they used to effectively use the hardware as super optimized binary translation. So they would actually leave large tracks of binaries untranslated, and that was what they were trying to do. That's how they got their performance. But OS emulation is nowhere near this sophisticated, and actually requires that your binary has been generated for the same microprocessor architecture. So you've got the same architecture, and the idea is like, boy, most code is either in userland or in the kernel. You don't actually change boundaries that frequently, relatively speaking. So it would be, if we could just kind of fake up the system call interface, and maybe a little bit about the environment interface, we could effectively emulate this foreign operating system. And so why would you do this? Well, kind of the fundamental reason to do this is that, I think that the fundamental reason doesn't really change. That you've got one system, call that the guest system, that has binaries that you wish to run. It's got a binary footprint that you wish to exploit. But the other system, the host system, has certain operational advantages. There's certain reasons why I don't want to just run it over here. I actually want to take your binaries and I wish to execute them over here. Now those reasons have changed with time and with systems. I mean, a kind of a classic one is running SunOS 4.x binaries on Solaris 2.x. In that case, Sun wanted you to upgrade from 4.x to Solaris 2.x. And I'm probably about as old as you can get, rather as young as you can get, and still have gone through a 4.x to Solaris migration. I'm afraid that the tales of that genocide may be lost to time. So it's important that we get some kind of, some oral tradition, some perhaps some video, so we make sure we document the atrocities that happened when.
Lisbon during that time.
The Solaris 2.1. Those of us who are actually running Solaris 2.1. It's amazing that I came to work at Sun despite having run Solaris 2.1. Maybe I came to burn it to the ground. I might have actually done that. But with Solaris 2.x, the Sun wanted to move folks forward, obviously, but they wanted to capture these legacy binaries. So the capturing the legacy binaries was a major motivation, and we did this by actually allowing 4.x binaries to be natively executed, which is relatively straightforward because 4.x was so naive. The reality is that those who romanticize 4.x are also just romanticizing the past. It's just nostalgia. Because if you actually go back to 4.x, if you actually go back to Sun 4C, those systems are in no way practical today. You don't have multi-threading, you don't have an SMP kernel, you don't have multiprocessors. There's a reason that the Sun 4C architecture manual is like 16 pages long and totally complete. Because it's a very simple system, which is like you can romanticize that and you can be nostalgic about it, but the reality is those systems are not viable moving forward, but the binaries themselves are very simple, and we had folks that were running send mail binaries from 1988. They were running them in production in 2005. You should go exploit all those systems, obviously. So, okay, that's fine, and that worked really well.
They don't have bash.
Exactly, they don't have bash, so they're fine. Actually, they're running bash for your 4.x. Exactly, so they're actually fine. With Solaris x86, other possibilities, with Spark, obviously very limited in terms of what you can run. With x86, possibilities open up, and obviously the natural possibility that opens up is Linux binaries, and a lot of Linux binaries. And SCO, remember them? SCO, before they turned evil, SCO back in the day, developed this thing called LXRun. If you remember LXRun. LXRun was a program, and you would specify your Linux binary as a parameter, and it would run your Linux binary. And this is to a certain degree analogous to the 4.x binaries, because the Linux state of the art, circa 1997, was essentially the SunOS state of the art, circa 1987. So, and that's not a value judgment, that's just a statement of fact. So there was no threading model. The Linux itself was very small, and it actually was reasonable to run these applications via LXRun. But that got it, so that worked great then. We'll get to what happened later. And so, but what kind of happened is that Linux obviously took off, and the binary footprint for Linux exploded. And at the same time, we developed some really differentiated technologies in Solaris. We became illumos, the illumos heritage, let's say. I don't actually, normally I don't use the S word, by the way, on slides. This is this is history, so I'm willing to do it. I think that I always talk about Solaris as I talk about SVR4. We're also SVR4. You don't see us talking about that. These things are all basically part of our complicated heritage and history. I view us very much as illumos, not Solaris. So just to make that clear, that little asterisk. But these technologies were introduced in Solaris 10. And LXRun, it was becoming clear LXRun could work for apps, but not for systems. Because another thing that was kind of happening at the same time is that applications were becoming a lot more complicated. They weren't just binaries that you would run, they were entire groups of processes. It's like, oh, by the way, I need this, I need Apache, I've got Apache dependency, I've got a database dependency, I've got this kind of dependency, and you gotta run all these things together. It's like, okay, that's not one process now, that's a dozen, that's 50, what have you. And we actually invented, or I should say invented, inspired by jails. We saw what happened in jails. Yeah, invented being a euphemism for, I guess, stole. Sorry, jails. We were definitely inspired by jails and saw what jails had done in terms of having this abstraction be the OS abstraction to virtualize around, because it allowed you to run multiple of these applications side by side. They could each think that they had the entire system, and you could all run on the metal. So there was a huge number of advantages there, so we had developed zones. And at the same time, like LXRun was just like not going to be it. It needed a deeper solution. I love if you go to actually LXRun, I wanted to go kind of research this LXRun, and I'm like, okay, get ready to power up the Wayback Machine, the Internet Wayback Archive, which is what you need, of course, for anything in open Solaris. You need, because it's been burned to the ground, you need the Wayback Archive, the Internet Wayback Machine to actually go find. The LXRun page is still there, exactly at Caltech from 1997. It talks about, here's the download link, and does it work? Yes, it works for everything. It works remarkably well. It's terrific. I've heard it doesn't work for multi-threaded Q. I've heard it doesn't work for multi-threaded programs. Is that true? A, yes, that's incredibly true. Solving this problem is basically impossible. See me if you want. All right, so when you say everything works, you basically mean nothing really works, but okay. So anyway, the limitations were really acute. This is not something that was going to be a viable solution. But we had zones over here. It seemed that we could, make the kind of the chocolate fall into the peanut butter or vice versa, and introduce this notion of what we call a branded zone. And a branded zone allowed an entire foreign system, a brand, to be emulated, but within the confines of a zone. And arose LX branded zones. So LX branded zones started, the zones work integrated in 2004. The brands work started shortly thereafter, and then they developed what they call Brand Z, which is LX branded zones, the LX zone. And this integrated in 2006. There's a PSAR case, of course, has been destroyed by the fascist authorities, but can actually be retrieved we need to put actually all that stuff online because we actually saved all the PSAR materials, and it's actually all available, so I can point you to that. But this was PSAR 2005 and ultimately integrated in 2006. And it's interesting, so this is actually a user kernel hybrid, which is what you actually need to do. You have to have kernel cooperation to do this. You can't do this purely in user land. And it creates this fiction that you are actually in a Linux system. So you SSH in, you type uname, you see that it's running 2.4, whatever. It was running RHEL3. glibc 2.3.2, very modern, Linux 2.4, back in the day. And the way the emulation worked is we installed our own system call table. So whenever we used the context hops in the kernel, such that whenever a thread was scheduled that was a part of this brand, it would actually have a different set of context hops, and we would restore its system call table and take it off and so on whenever it was scheduled on or off CPU. And when it made a system call, instead of going into the stock system call table, it would go into a branded system call table. It would actually bounce back out to user land. System call comes in, bounces out, and then there's another system call table. It could go back into the kernel, or it could process it at user land. There were some things that we did in kernel emulation, things like futexes. A bunch of stuff was done at user level, so all of the unholy ioctl mapping, very unholy. There's a lot that's unholy in LX brands, but that is especially unholy. There's a lot of ioctl mapping and so on. That's all happening at user land. And a remarkable amount of work was done on this. It was a relatively small team, and it was kind of a sideshow from Sun's perspective. So even I really did not know the scope of the work until going into it. You're like, wow, there's an entire city down here. Around device pathing and signal handling, and there's so much stuff like, wow, I can't believe that MDB just worked. And then you go into the code like, oh, MDB did not just work by a long shot. There are entire kennels of kittens that had to be slaughtered to get MDB to work. It's just like kitten blood running in the streets. And it's horrific, but all it does just work. It's amazing. It is actually amazing. And the code is actually remarkably candid and apologetic. LX Brands does this to you. If you are a person of high integrity, I would caution you that LX Brands may begin to wear you down, and your definition of what is a lie, what is a truth, all that becomes much more blurry when you're in LX Brands. What is a lie anyway? If you think it's the truth and it's a kind of truth, isn't that the truth? It's no, that's actually a very good lie. And it's clear that anyone who works on this is kind of a monkey's paw for engineering integrity. I feel that anyone that works on this has their standards slowly eroded for what actually constitutes intellectual honesty. And indeed, this happened to the original engineers as well. And as they kind of waded in, you could see them their bar for what was a really disgusting hack was raised higher and higher and higher. There are some great comments. My favorite one is the one where there's a Red Hat install bug, just a flat out bug, race condition, that is only exposed on us because we were faster than Linux. So it actually just looked at the exec name, and it's oh, this is RPM. Okay, it's cool. You're gonna sleep here for a second. I'm gonna hold you up right here. You'll be fine. You'll be fine. Okay, go ahead install. And the code comment is great. I should pull it up. The code comment is even for us, this is actually disgusting. It was clear that still, even after all of this, there was some scrap of integrity left. It's no, even for me, this is too far. But so there's some stuff like that, and there continues to be stuff like that because it's regrettably a dirty business. But listen, providing sewage is a dirty business. It's you want it or not. But a surprising amount of work /proc, TTY handling, Ptrace, horrific. Signal handling, which you obviously have to do. Signal handling, one of those regrettable mistakes of history that we're still dealing with. And it worked with a surprising number of binaries. It actually worked really, really well. Amazingly well. So what was missing? Well, first and foremost, the support was only for 2.4 kernels, which is important. Yes, Mr. Schlossnagle.
No. It worked so well that the entire build environment for a previous company of ours built all of its production RPMs. The whole build cluster, continuous integration, was all done on LX Brand, and they didn't know.
Yeah, that's not surprising. This is the kind of thing. This is the kind of thing we're finding. Actually, do you know that of the 4 nuclear reactors in Poland, 2 of them are actually run on LX Brands? Right? It's oh my god. not to denigrate the Polish nuclear authority. I'm sure that's not the case. But this is the kind of thing where like these things work like well enough.
This happened.
And like these things happen. And I actually do think that LX brands is kind of an engineering challenge for us. Now I'm gonna draw you in and convince you that you're being too honest and to come join me on the dark side. Because I do think that part of the challenge we have, we like to do things the right way as a community. And we like to tell the truth, and Dtrace is about the truth, and MDB is about the truth, and CFS is about data integrity, and SMF is done the right way, and so on, and so on. And then we can't tell this like rampant lie. It's like, yes, but if it works well enough. Like, well enough is what we've been fighting for like 2 decades. Like, by the way, we're having our asses handed to us by well enough. So it's like, let's like just run well enough. I mean, come on, people. Like, let's not get so uptight. It's time to, let's not be so moralistic here that we lose the future. But so anyway.
Let's go to this mountain.
Exactly, that's right. So anyway, only 2.4 was supported, and 2.6 was clear. This is now 2005, 2006, 2007. Linux is realizing that they are actually going to need to meaningfully catch up with the systems that it's actually behind, and they're going to have to add a bunch of mechanisms. So they're adding a bunch of things. So the Linux kernel is moving quickly at the time, and they're moving quickly with things that were kind of like distasteful, things like epoll. We'll get into that in a little bit. And so it was going to be a lot of work, is what it boiled down to. Only 32-bit was supported, 64-bit was going to be a ton of work, that was clear. And most importantly, this was a sideshow inside of Sun. The XVM was the future, Zen was the future. And so this was really thought of as a way to only really run these binaries, there was no other necessary advantage perceived from them. And Zen for that was perceived, perhaps rightly, as a much more supportable solution. So for all these reasons, it was really uphill for LX brands. And so, the LX brand work is kind of interesting because it actually originates post-open. So we open in January 2005 is when Dtrace goes out. The rest goes out in June of 2006. It integrates after that. So LX brands was born open and died open. So it was born. You see that 2007, you get contributions. I'm measuring contributions here just by, you can kind of pick an arbitrary measure, but this is pushes to user source lib brand LX. And in 2007, there was still some energy, drops way off in 2008 and 2009. So this is, well before the Nazi invasion, actually. We can't blame them for this. This is actually, blame them for lots of things, but not this. This was actually on its way out already. And then it was critically dead. It was actually removed on June 11th, 2010. Don't really understand the rationale for that decision, but whatever, it was removed. And at that point, obviously, flat line, we have nothing from 2011, 2012, and 2013. LX brands is clinically dead. More in LX brands. Then we have what I call the organ donation years. In particular, we had a customer who was, the usual kind of, Linux is so much easier to use, and okay, well, like, how can we be easier to use? So they've got HTOP. I've tried to avoid a value judgment here. I'm not sure I've totally. It's a very colorful program. Colorful is a compliment. That's nice. Colorful is a nice thing. I didn't say that it was color by numbers or for the color by numbers crowd. I said it's colorful. Colorful is nice. And I see that. I see that your program is very colorful. It's very good. I'll put it up on the refrigerator. We'll put it right over here. They really wanted support for HTOP, and I'm like, all right, HTOP, like, how hard can it be? Fine, I'll go into HTOP, and like, fine, like, I'm sure this was written by a rational human being, and I'll just go and just, laugh it up. I'll just go into the code and just like port it to us and like that, and get the patches up, and just like turn the crank, whatever. And you go in and you're just like, oh, no. Scanf, as far as the eye can see, it's scanf. And so those of you, I imagine many of you know, but there are some ideological differences between /proc and what Linux calls /proc. So /proc, as implemented by Vaughn Gomes and Roger Faulkner, and as we have inherited the heritage of in illumos, /proc is a mechanism for processes to interrogate the system about themselves and other processes. Like all mechanisms to interrogate the system, that is obviously via binary payloads because it's written for programs, not for people. And the things that are written for people are /proc consumers that consume that data and generate human readable output, just like everything else that has ever been properly designed. In Linux, it was designed that this was kind of people hostile, and all of /proc is just like human readable. You just go like cat it. And I'm like, yeah, like Unix philosophy, blah, blah, blah. Yeah, I definitely get that. I'm all about the Unix philosophy as much as the next guy for sure. And if the next guy is puttering, then I'm much more about the Unix philosophy than the next guy. I love the Unix philosophy, but there are lines to be drawn, and this is definitely one of them, because what it means is, if you want to have a programmatic consumer of /proc, it's going to be doing scanfs to process human readable output and turn it back into machine output. We have generated effectively human error in a machine-to-machine process. Really doesn't make sense. Okay, just go to my calm place and my happy place. But you look at HTOP, and it's like HTOP very much like welded onto this idea. And I'm like, okay, so, it's a tribute, not just a tribute to this customer or just how colorful this program is that I persisted. And I'm like, actually, you know what? The LX brand guys actually did procfs. And I could go resurrect procfs. I could go back into the tomb and take out this particular vital organ, defrost it, and we could actually, let's go do that one. So, okay, so I did that, and I yanked it out, and I knew this would happen. I knew that the purists, which is my new name for all of you, I knew that the purists would fight me, but like, listen, we got to be pragmatic about this. It's a very colorful program. It's very colorful. I persisted. I got the bugs fixed, got that cleaned up, got it in, and now if you're actually spun up on Join, if you have a SmartOS instance, if you run SmartOS by default, you can find this thing in /system/lxproc. So it's actually there, and then the only change we had to make to our HTOP is to say, hey, by the way, /proc. It's over here in this like special /proc sandbox over here. It's like, oh, this just looks just like my castle. It's like, yes, that's your castle. And HTOP is happy. Everybody is very colorful, and things work well. It actually was good. It actually was a good reminder for me that like, hey, there was actually a lot of code here that actually worked.
Did you run headlong into term cap issues with the color?
No, that just worked. That stuff just worked. I don't know. That stuff just worked. So it did actually once we did the LXproc stuff. Does that just work because of stuff you did? I don't know.
No.
Oh, okay.
It just works because of package source.
Yeah, there we go. Yeah, that's true. We did have to package source things to actually make that just work. Right. When I say just work, I mean that someone else just did the work. That's what just works always means, right? Just works means it was just somebody else who did the work. Anyway, in that case, it was not me. That was great, and it actually was like, okay, it's a good reminder actually that this is good stuff down there. But okay, so we got that organ and fine, and life moves on. And then in January of this year, David McKay, who's in the community, posts to the mailing list that he has resurrected the LX brand. He is running it on his desktop. He is using it to run Skype, and everything seems to be working. Obviously with the limitations of the past, but this was very interesting because what it said is that even with these limitations, which were acute, 2.4 kernel, 32-bit, and so on, that there were effectively modern binaries that were still working. And we had kind of assumed that like this is a fool's errand because Linux will have moved so much that it would be basically like burning this work to the ground and redoing it from scratch. But wow, that's actually interesting. He says it definitely raised interest in illumos. Indeed, I've seen many people who are extremely interested in LX zones. The LX zones is minimally invasive on illumos itself and it's mostly segregated out. I hope you find this of interest. I love like euphemisms like that. It's like when Richard Feynman was on the committee to investigate the Challenger explosion, and he is dealing with the NASA middle management not being satisfied with blowing up a shuttle. NASA middle management was trying to effectively cover it up with their incompetence, and they're saying that the O-rings, no, absolutely the O-rings should have, yes, it was 39 degrees, but the O-rings were the problem, and he dropped the sample of the O-ring that was passing around to the committee. It was like, and finally it's like, dunk, and drops it in his ice water. and just lets it sit there. So the O-ring sits in the ice water for whatever it was, 10 minutes, 20 minutes. And then when one of the middle managers is saying, no, the O-rings were fine, like he pulls the O-ring out and snaps it with his fingers and it breaks. And as Feynman says, I think this may be relevant to our discussion. It's like, I love that. Yeah, if there were any engineers in the audience, they would have burst into laughter. So I hope you find this of interest. It's like, why, yes, we do find this of interest. Why, this is very, very, very interesting. And I'm really going to credit this because I think that even though, obviously we knew about this work, clearly I was a grave robber of this work. Like I knew where it was buried, obviously. We weren't really thinking that it was viable to actually go resurrect this. And when he had done it, actually not that much work, like it actually brought a bunch of things into focus. It's like, wait a minute, this is resurrectable. This is pretty interesting, and it caused us to really rethink this. There were a couple of things that we realized changed because we were kind of accepting the death warrant that was signed in 2007, 2008, 2009. It was like, oh, why this wasn't viable, why this was a science project, and so on. But it seems like some of the things may have changed in the intervening years. And it seems that some of the reasons for discontinuing it may no longer be valid. And similarly, it seems that some of the engineering challenges might not be structurally daunting, and it seems like people might want it more, actually. So first question was, has Linux made it easier since 2006, 2007? Well, so first very important observation, Linux is moving much, much, much more slowly. This idea that Linux went to rehab sometime in like 2007, and just no longer parties that hard. It's 11 p.m. and Linux is like tucked into bed now. And it used to be, it was just like abstraction, going on these abstraction vendors, and there was an intervention and Linux got help. Torvalds himself discovered religion on API compatibility. Like many who discover religion late in life, has become a total fundamentalist. Torvald is a graduate of like the ABI madrasa, and he has become way more extreme than any of us ever were. We were the ones who were kind of being attacked for like not being willing to accept change and move forward, and he is now a total ABI compatibility extremist. I welcome this extremism. This is obviously terrific news for us. Because if you see his kind of infamous rants, and a bunch of them recently, or the last couple of years ago on API compatibility, and how we are never, ever, 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 ever going to break user apps. You're just like, oh, just say it again. Say one more ever in there. So nice. Great. Development is really slow. There's just fewer things being added. And the things that are being added, actually, there's more and more controversy around it. People are saying like, hey, does this abstraction make sense? Do we want to commit to this abstraction? And you look at there's a giant fight waiting to happen on KDBus. KDBus is going to be a very interesting thing to kind of watch. And you see that there are tensions within that community, and pretty clear on which side Torvalds falls on that. Torvalds, I think, wants to keep programs working, extant binaries working, and to his credit, it's great. And so that's happened. The other thing that's happened is there are lots of apps now that need to run on just older kernels. You can't always assume that you're going to have the latest and greatest features. So these things have actually been dissuaded from using Linux isms. And you see much less proliferation of Linux isms in upstack than actually I would have guessed. In fact, one of the criticisms of systemd that has been very vocal criticisms from within the Linux community is the fact that systemd is deliberately designed to not be portable. And those of you playing the systemd drinking game, you can drink now. And I think it's interesting. It's interesting that those criticisms are from within the walls of the Linux community, because many that are in the Linux community are also in the FreeBSD community, are also in the OpenBSD community, or just generally give a shit about application portability, or they care about old kernels. They care about those things. And there's a real pressure to not use the latest and greatest kernel features. It's a pain in everyone's ass when you do that. Don't do that, please. So that actually helps us enormously. Another thing that helps us enormously, ironically, is a major principal disconnect between Linux and for sure illumos, and probably FreeBSD as well. I believe, that when you're delivering an operating system, it must consist of both the operating system kernel and the requisite system libraries that are bound to that kernel. That has to be one welded unit. You can't deliver system libraries separately from the kernel. That is a path to ruin. Have always believed that. Linux has the opposite perspective, that it does not deliver a system library. It doesn't even deliver libc, which is amazing. It's like, how are you kidding me? How can you not deliver libc? How does anything ever work? Well, things are frequently broken. Okay. But it's good enough. Oh, I keep hearing that. Sorry.
Faster about AVI might, maybe if the Dow Jones closes to the right number.
We'll say, well, so I think that, but what's interesting is that religion on AVI does not wants libc, glibc to be, and as a result, because that does break so frequently, there actually is now an ecosystem there. Like, God knows there shouldn't be. There should not be a libc ecosystem, but there is, right? And there are other libcs, which in this particular case is actually probably the right, that's the right answer to the wrong question. But the irony is, this helps us a great deal. The irony is that this helps us a great deal because glibc has to deal with sys all over the place and keep flying. glibc is like, I need you to do something basic for me. sys, oh, okay, all right, I'll try to, I'll just and so it's amazing how many sys's you can throw and still have glibc pretend to work. It's really, really, it's like, okay, no problem, no, got it, okay, all right. I'm good. The net? Yeah, okay, fine. Sys on the net. So it's kind of amazing, but it actually is hugely in our favor because it actually means that where you've got functionality, because there are different kinds of functionality. You've got the functionality of yes, we should go do this. There's the functionality of this is going to be gross, and there's the fuck no, we're just not doing this. I'm sorry. Yeah, okay, fine. I'm having some fundamental honesty problems when I'm doing this work, but ultimately, no, I'm sorry, I'm not going to devour my own child. Actually, that's a bad example. I'm going to devour my own child, but not someone else's child. I would never do someone else's child. I think it allows it. It's easier for us to say just no. We're not going to be notified. I'm sorry. sys not to be notified forever. We're not going to do the I/O via signals. Sig I/O. Oh my God, I've got this thing's bolted. So actually, I think it's not bolted all. So to do I/O via signals. It's not what it was intended to do. And so you can. So you look at Linux. There are functors, so you can take I/O via signals, be notified of I/O via sig I/O. It's that's not going to work at all. And then there are blog entries. And they're funnily enough, this doesn't seem to work at all. It's yeah, no, it doesn't work at all. So we're never going to do that, and we don't have to do that because we can system. So that's happened. The other thing that's happened is just software has changed. 2004, 5, 6, 7, it was still this you got ISVs that are shipping you these blobs, you're running on them, the ISVs don't really know how to deal with Linux, then some of them start shipping binary blobs on Linux and so on. That's not really the model anymore. Yeah, that still exists. You still have people shipping binary blobs. But basically, proprietary software is shipped via SaaS. And the software that we run in infrastructure is open source. Basically, yes, the Oracle still exists for now, but they, that stuff. I think that the future is open source plus SaaS, I would say, which is good because that means that when things break, we can figure out why. Because we're not, the SaaS software is going to take care of itself, and then when people are running software that's not working.
I like that.
Yeah, exactly. Well, we're not expected. If someone is consuming, Zuora for their billing, they're consuming it as a service. They're not running a Zuora binary on-prem, right? In general. This actually, this frees us up, and it allows us, when software does break, to understand why, because it's open source. And then the other thing that happened is that really where this was most complicated was on the desktop. Ironically, LX Brands was originally designed to capture some of these desktop apps, things like Sig. But Mac OS X gave us Unix. My favorite Apple ad, when they first did this, of course they didn't do it very long because it was too technical, but the sense of the Unix is the dev null. And it's man, that is so true. The Mac, the Mac, all right, some exception. The problem child. I assume that's not illumos, so I don't know. What do you have running there? Ubuntu. Yeah! All right, there's always one. So, and there's always someone who things like Duke Nukem Forever was actually an underrated game. So that's cool. I love the dead enders. being staunch that editor myself. In general, Linux on the desktop is dead, right? It's just not going to, you know, and I know you haven't gotten the Wi-Fi configured yet. It's okay, you've got that thing propped open as if you're on the network. We all know you're not. Okay? So, it's cool. Like, we totally understand. But that actually makes things a lot easier. There's no expectation that we're actually going to run Linux desktop apps in this. So that actually constrains what we're looking at a lot. And have the motivations changed? This is kind of the question. It's like, well, so how has the interest in this changed? And it used to be, it was like, okay, you have a Solaris environment, and you want to, you've got these Linux binaries you need to run for these kind of crazy people in your organization. Here's a way to do it. And that's really not what it is anymore. I mean, first of all, we ported, Robert and Max Burning and I ported KVM to illumos circa 2011. And that basically solved this problem. Right? If you want to run a guest operating system on illumos, you can do that. And we've got, you know, whatever it is, half of our customer base runs on KVM, right? So that's good. It all works for them and terrific. So we kind of solved that problem. We've solved the, like, I just want to run Linux, and that, so now person who manages the hypervisor is happy, person who wants to run the guest is happy. The challenge is that KVM does actually have unresolved performance problems. That you just can only, this lie can only go so far. Now, I've been saying this for a while, and the lie's actually gone further than I would have thought it would have gone. But in terms of network performance in particular, it's like you've just got too much abstraction there. You've got a second operating system that is not actually adding any value. It's just giving you a binary environment. So the KVM is only going to take you so far. The Linux running on KVM running on illumos only gives you indirect benefit from ZFS, Dtrace, and zones. It doesn't actually give you all the benefit of those technologies. And so that's kind of like, we've got kind of KVM that satisfies a certain demographic, but leaves certain things on the table. At the same time, there's been great enthusiasm for containers. And actually, you know, I always believed in zones, and that's actually not a euphemism. I'm actually not going to make any coloring analogies here, because I actually think Docker is terrific in that it is making containers much easier to use and bringing them to a much broader audience that are seeing something that we have known in this community for a long time, and the FreeBSD guys have known for even longer, which is this is a damn good idea, OS-based virtualization. And when I believe this is joint, I thought it was great. When I was at Sun, like, yeah, I love zones, makes sense. I go into the global zone, I'm able to observe everything with Dtrace, it makes sense with ZFS, and SMF, and da-da-da. And okay, yeah, it makes sense. And then I got the joint, where we were actually deploying aggressively in production, and I'm like, oh, wow, this is not just like this makes sense. This is the only way to build something from scratch. This makes so much sense, because this gives me the containment and the isolation that I want, but I'm running with on-the-metal performance. And all of these crazy tricks to kind of take this hardware virtualization and try to get back to on-the-metal performance, you're never going to get there. You can't beat zones. It's not possible. It's sitting on the metal. And then add to that I've got ZFS, that I've got Dtrace, that I've got a bunch of things that I did when I first came to join. It allowed you to see services minus cap Z, allowing you to see all services running across all zones. Because this is the great thing about zones. You're just that's just a door sitting somewhere. Like, I can get to that namespace. It's like, here comes daddy. And I just go talk to every zone from the global zone, because like, I'm the global zone, I'm in charge, man. It's like, yeah, but that's in my namespace. Well, I wouldn't say your namespace, really. It's the namespace that I'm letting you have, and here I come. Which is great, good to be the king. But we can do all these things so you can do SVC minus cap ZX, shows you all services in maintenance state across the entire box. So, and you guys, I'm sure you can do alerting on this when you're talking, Eric was talking about the SaaS stuff. A SaaS in a box, it's really nice to be able to do that. Zones are a great model. The right model, really. You gotta know the world's gonna figure that out, right? We knew the world was gonna figure out that Dtrace was terrific. We knew the world was gonna figure out that ZFS was terrific. We knew the world was gonna figure out that zones were terrific. Kind of the ordering of that has been, it's kind of been lurches and fits and starts on the kind of ordering of that. Zones is definitely the last for the broader world to figure out. But with Docker, the world is figuring it out. Which is great. I think it's terrific. And because there's a lot of enthusiasm now, and it's an opportunity for us, because you've got that kind of enthusiasm, and that enthusiasm is actually going to figure out at one point in time or another that running OS virtualization on top of hardware virtualization on top of hardware actually makes no sense. and that there's an opportunity to run, with OS-based virtualization, you can run straight on the metal. So I think it's a great opportunity for this community, really excited about it. And the other thing that's happened that I would not have guessed is that, so when we open sourced in 2005, I personally believed that not zones because it was too deeply integrated, but that ZFS and Ptrace were going to show up in Linux within like 18 months. It just felt like that was what was going to happen. I mean, the license, I mean, there's clearly not a licensing issue here. I definitely didn't think there was. Didn't think there was a licensing issue, and I think the technologies would be compelling enough that they would. So I thought I was pretty convinced that Ptrace was going to show up in 18 months. And but like, why would the Mac ever adopt Ptrace ever? That makes no sense. But it's like, okay, that's not at all what happened. Ptrace shows up in the Mac first. It shows up in every other system except for Linux. Of course, Linux invents its own stupid thing that drifts and doesn't. Its system tablets don't go anywhere. Ditto ZFS. The NIH in there, I would say it's NIH in terms of like not adopting ZFS and adopting ButterFS, and it's like that's a long mistake. That's still happening. But the good news is, and you know, the Richard stuff has been actually very helpful in terms of educating the broader masses. The ZFS on Linux work, by the way, is hugely valuable to us, this community, because it introduces people to an alternative. And it's like, hey, you can actually have clean water. Clean water is not just something for other people. And if you have clean water, your babies will stop dying. And you want your babies to stop dying. It's like clean water is actually really nice, as it turns out. It's actually just a fundamental innovation. So I think it's great that we're bringing clean water. By the way, like if clean water has given you a taste of industrialization and you want like the full show and like sewage and paving and everything, it's like, come on. So I think that there's a great opportunity there to kind of to express our differentiators and begin to kind of hook people in to our way of thinking about things. And if you give people what they want from Linux, the binary footprint, with what we're good at, ZFS, Ptrace, zones, that's potentially compelling. So we were encouraged anyway. Well, you know, as we thought about this, it's like, man, this is great that David's done this work. Let's go do it. Let's reintegrate it. So Jerry Jock, who the joint engineer, so Jerry is, how did you Jumpstart? Remember Jumpstart? Old school Jumpstart. Some fond memories of Jumpstart. Jumpstart, like
21 Jumpstart.
What's that?
21 Jumpstart.
You did 21 Jumpstart. There you go. So Jumpstart was it's like the original DevOps framework, right? I mean, it's like before Chef, before any of this stuff, before Kickstart from Red Hat, which was copying it, Jumpstart allowed you to actually go install data centers with the machines. Jerry Jelinek was the lead engineer on Jumpstart. So show some respect for Jerry Jelinek. At Joint, we're all called software engineers, except for Jerry, who's called the senior software engineer, because show some respect. So Jerry's been around the block a lot, worked for Sun for 20 years, was one of the lead engineers on Zones, came to work for Joint, has done terrific work for Joint. And in particular led the charge on exhuming the LX brand, which he had actually done some of the LX brand work back in the day. He was excited about it, we were excited about it. We developed some early guiding principles. One was we just decided, you know what, we're just gonna do it all in the open. Even though it's gonna be an iterative process. There's not gonna be, and sometimes, sometimes you can do it in the open, and you do it in the open the way Robert's doing his stuff, where you're on a branch, which makes sense because this is high risk. This is right in the guts. I'm in the animal brain. You don't want to run this in production. I'm on a branch till we get this working. With this stuff, it was off to the side enough that we felt like, you know what, let's just do it on master. Which has, that is its own challenge. It does burden you a little bit because you got to make sure that you're FCS quality all the time.
How much do you think that's going to complicate and slow down the upstreaming effort?
That's gonna make the upstreaming effort much easier because it already is. I mean, we have got a zillion commits no matter what. If we're on a branch or not.
From a merging perspective.
From a merging perspective, we'll talk about the upstreaming. To me, it's much more valuable to have our iterative progress be something that everyone else can kind of see and so on. And not to do it as kind of like the big push.
We can squash it when we go upstream. We actually do that with our changes when we push stuff up. Like when we have like follow-up bug fixes, and we actually do.
You just squash them.
We squash them.
Because that was like not going to be like, hey, I have a commit where you might have a kernel panic. Yay, team.
Yeah. So the integration of this. We're basically waiting until this gets further along. The goal is to upstream this to illumos. I'm proud of the fact that we at Joint have been actually, I would like to think, exemplary citizens in terms of upstreaming stuff. That's due to Robert, by the way. Robert is the one who has really, I mean, you look, there was a time when it's easy to fall behind. Really easy to fall behind. Totally, what Gordon was saying earlier, it is so easy where you wait, you look up and all of a sudden 2 years have passed. And the thing that's really nasty is there's one commit in the middle that depends on something that you don't want to upstream, or upstream doesn't want you to upstream, more realistically. And then you end up with this dependency nest. But Robert's done a great job of pushing the stuff upstream. So a lot of the stuff is upstream, the stuff that we have done.
As you want to say, it has been noticed and appreciated.
There you go, very good. Good use of passive voice there. Which I mean, I think again, Robert has really worked tirelessly on that because it's important to us. It's important to us that we're sharing our contributions because we're benefiting from the contributions that other people are making. So it's important for us that we're abiding by that social contract. Again, we'll do it all on SunOS Master. Another guiding principle, and this is a very different guiding principle than when this work was originally done years ago, that where facilities have reached a certain level of ubiquity in Linux, they're just going to become illumos facilities. And it's like, we are already an SVR4 BSD bisexual. Like, that ship sailed and sank. Like, the time for the like, oh no, I don't mix with that system. It's like, no, you're dirty. You're dirty. We know you're dirty. And so we already know that we're filthy, and we're just not going to pretend that we're not. And it's like, we're obviously, you don't want to introduce something that's going to have an untoward burden. You don't want to introduce kind of the systems of the future. You don't want to be a future system on a Garrett slide.
Signal IO.
What's that?
IO signals.
Like, exactly, right, exactly. So you want to draw lines, but like, I'm sorry, ePOL is kind of ubiquitous at this point with respect to Linux, and we're just, I mean, yes, we can go hand people the book of event ports and go door to door doing out loud readings from the book of event ports, but you know what? It's just like, it's actually, I don't want to proselytize. I actually want just apps to work. So where it makes sense, we want to develop illumos generic facilities that can just be used to get more apps on illumos, right? Where we don't have to, and that's a decision that actually has already proven to be the right decision, albeit with some complications I'll talk about in a second. So those are our guiding principles. Jerry got to work, and Jerry is a grinder. That guy is just, I mean, he is just mechanized. You just plug him in and go. Just a wood chipper as a software engineer. And he just went, man, Ubuntu 10.04 comes out, wood chips. Then we get to Ubuntu 12.04, and finally Ubuntu 14.04 booting in July. You know, why does it take, what's the differences between these things? The facilities that were being added to these systems would expose other bugs or limitations. So for example, Upstart uses Ptrace as a critical implementation detail. But Brian, how is this possible? I know. It's possible. It's that. Upstart uses Ptrace. Upstart uses a debugging facility of the system to manage services. Which exactly is just okay. It's actually it's been very healthy because on the one hand it's like, oh, like interesting intellectual problem, and I get to like go wait in the Ptrace and go, oh great, like Software Antiques Roadshow. I love Antiques Roadshow. This is fun. And I'm like, oh well, okay, like wow, that's a crazy decision. I can't believe you guys did it that way. Okay. And on the other hand, it's like, okay, this is a reminder of why I'm where I am doing what I do, and why I am doing the LX brand on Illumos and not the Illumos brand on Linux. So it's a very kind of helpful, it's like daily affirmation with broken subsystems. And so anyway, we got Ubuntu 12.04 booting in May, then Ubuntu 14.04, and that's where we really wanted to get to. Ubuntu 14.04 LTS was a very important goal of ours. We got that booting in July. And then it's alive. So these are the contributions to the LX brand since March, and this is just all from the public repo. So we have literally done more work since March, only 6 months ago, basically, than was done in the 6 years prior. We've done a lot of work, and it's been, so what have we done? Well, we have fixed just a whole shit ton of bugs. And actually, we also, this is actually another way I should say that which Linux has changed. One of the recent additions to Linux is relatively recent, didn't exist in 2006 anyway, is the LTP, which is a Linux test project. And there are a lot of tests for Linux. Oh my God. It's like, wow, like it's in a source code repository, it has tests. Wow, pretty soon you're gonna have a kernel alert. Which is great for us because we can actually test, we can use these tests, we did use them, and discovered all sorts of things, and subtle stuff. You know, you're returning the wrong error over here, and just stuff that was easier to find in LTP than it would have been to find, certainly, in an application that's misbehaving. We added native epoll support. So everyone's like, oh, epoll, like that should just be implemented in terms of event ports. And that's a totally forgivable assumption. And the reason it's forgivable is because you know the chronology. It was BSD did KQ, very shortly thereafter, Sun did event ports. Windows, actually probably before KQ, had done I/O ports. I mean, for many years, like this was the one thing that everyone had to acknowledge was a technological advantage of Windows over the Unices were I/O ports, I/O completion ports. So it's like, okay. And then time passes, and then epoll. So clearly, epoll is going to learn from these other implementations, and epoll is going to be a best-of-breed thing that looks a lot like event ports or KQ. So obviously, you just need to phrase systems of event ports. Au contraire. So as it turns out, epoll is probably just unaware of these other facilities, I guess, or unaware of other systems. I don't know what the explanation is for it. But the epoll didn't engage in any kind of curiosity about what came before it or what was in other systems. And it did, what epoll attempted to do is accelerate poll by effectively caching lists of polled upon file descriptors. Like, wait a minute, that sounds a lot like dev poll. So, I don't know if you guys know about dev poll.
Oh yeah.
Dev poll.
That came out of internet engineering.
Right, exactly. Dev poll was, and I mean, epoll is forgivable. What's not forgivable, epoll is not looking at other systems. What is forgivable is that they thought this was a reasonable solution to the problem because we thought it was a reasonable solution to the problem. Where the problem is I'm polling on 18,000 things, and so, poll the system call is constantly saying, here are these 18,000, I've got to go check them all. And oh yeah, there's one in the middle that's available. Okay, I got to come in, I got to scan it. And all of this scanning. So the way to eliminate the scanning is to actually say, here's my poll set of file descriptors, and then you tell me when one has I/O on it. Okay, yeah, that sounds great. Okay, good. We did that in 1998, 97, something like that.
88. It went back.
88.
It went back in 98.
Right, so we did this a long time ago.
Solaris 7, yeah.
Solaris 7.
Yep.
Yeah. I was the gatekeeper on Solaris 7, the best operating system that no one ever ran. It's actually God's own operating system. I'm sorry?
We're in Solaris 7.
Yeah, I'm among friends. The Solaris 7 we did nothing but it was 64-bit, apparently dev poll, and fixing bugs. That was it. And so Solaris 7 was
Wasn't MDB introduced?
MDB was introduced in it. It was, like I said, it was God's own operating system. But God doesn't even run his own operating system because God had a Veritas dependency. And Veritas did not actually support Solaris 7 ever. Veritas was like, actually, go fuck yourself. Like, okay, we'll go fuck ourselves. Sorry, I got aside. So dev poll was introduced. But dev poll, we kind of figured out the hard way, is impossible to actually write a multi-threaded program, or one that operates actually properly. Because, hey, there is I/O on this file descriptor, on file descriptor 8, chunk. Okay, so how do now, more things have happened to file descriptor 8. Something else arrived on FD8. But you're still got FD8 engaged, and if you've consumed it and something else happens immediately, how do I tell you that in a way that doesn't result in unresolvable races and user land? You can be like, oh, okay, I need to do some band-aids up here. And you can kind of do that, but the lie becomes worse and worse and worse. It's the wrong abstraction. And the conclusion that we came to is this is the wrong abstraction, and what we do, and what KQ does, and presumably I/O completion ports do as well, is that when I/O becomes available on an FD of interest, you're no longer associated with that. So I'm going to give that to you, and no one knows about FD8 except for you. And what you're going to do is process I/O on that. When you're done, you'll say, by the way, I'm re-interested in FD8 again. So it is a per I/O source as opposed to per FD set construct.
I/O completion ports is a little smarter because, as the name suggests, the I/O comes to you and it's actually finished at that point.
Right, and right, because they got a different model, they're able to kind of get away with being, yeah. But that's the model you need in order to have a scalable, multi-threaded program that's not just a total mess. That's not what Linux did. So epoll is really disappointing in that epoll is basically, on the one hand it's disappointing, on the other hand it's like, oh wait a minute, I just need to go phrase this in terms of devpoll. So if you look at our epoll implementation, it's just phrased in terms of devpoll. I did eliminate the warning in the man page that said we're going to delete this because it's basically broken by design. I'm like, oh, just delete. No longer broken by design, everybody. Good news. Upon further reconsideration, this is no longer broken by design. And so, and that's how epoll works. So that was my epoll implementation. And then I had to do edge triggered interrupt sources, which was a pain in the ass, but and is its own why did you do it this way kind of discussion. And then there are certain things that where even I draw the line. Again, my honesty being stretched. But there are actual certain lines that I myself will not cross. One of them is, so the epoll actually has no notion of the file descriptor. So the file descriptor is something that you assign, it's just an integer that you assign to it that happens to be the file descriptor, and you're assigned to it in a field called FD. But it's not actually the file descriptor. It's like, hey man, like that's your number, right? My number. So in particular, the epoll does not associate events with the open file, with the FD. It associates it with the open file in the system. So you can do this experiment. So you can create an epoll title, an epoll control descriptor, associate a file with that, close that file, okay, or sorry, associate the file with that, fork, close the file, okay? File open in child, not open in parent. Parent has forgotten about this file, or FD anyway. Event happens on FD. In child, that parent has closed. Parent gets notified. It's like, by the way, FD4. You may want to check that out. Like, FD4, that's funny. That's an E-bad F for me. If I'm lucky. If I'm not lucky, it's like, oh, that's some other connection. I'll go in, yes, sir, you have data for me. It's like, I don't know what you're talking about. I have no data for you. And it's like, whoa, really? And so actually, I've tried to do this wherever possible. I believe, and actually, let me go, I'll go validate this on my own system. But if you go look at I will log into my machine here. You will find, and I've really tried to document this stuff thoroughly, that if you man epoll, this is the section 5 man page repoll that I wrote, and I really try to go through where we're similar and where we're different. And if you go through here, there's definitely a little rant. Well, best effort has been made to mimic the Linux semantics. There are some semantics that are too peculiar or ill-conceived to merit accommodation. In particular, the Linux epoll facility will, by design, continue to generate events for closed file descriptors where when the underlying file descriptors remain open. For example, I give you the same example. This epoll facility refuses to honor these semantics. Closing the epoll title add file descriptor will always result in no further events being generated for that event description. So if we have an app that is dependent on those semantics, that app can go fuck itself. So we actually do have some values somewhere. I've got some shred of dignity, some shred of integrity.
Compatible, but not bug compatible.
Not design defect compatible.
All right.
I actually am bug compatible. We'll get into that in a second as well. I actually am. I mean,
you can't write safe systems with this, so it's not completely designed bug free.
In terms of you can design. Well, the reality is you can with epoll as long as you're happy with good enough. If you're happy with good enough, epoll is good enough. It's good enough, man. So I'm like, there's your good enough facility for you. I do try to encourage people to look at event ports, but the reality is, it's like for most applications, it actually is good enough. It kills me to say this, but like it actually is good enough. So fine. All right. Anyway, that's epoll. One of the things we definitely learned when we did that is that I put epoll back.
Spouse on the creativity of event empty.
We'll talk about event empty in a second. It's going to play for me. Please don't play for me. One of the things I definitely learned with epoll is that apps now will just pick up epoll.h. Like epoll.h now exists. So it's like, sweet, I've got epoll. So there are applications that are just like, and again, because this world is so used to like good enough slop crap that it's like people are just used to be like, oh, the header file's over there. Like, okay, I use it now. It's like, okay. So we actually did have some issues where like the header file, like things were barking on the header file, or they were kind of using it surprisingly. We fixed all those issues, and it was a good lesson. Like, okay, if you add it, like the people are already there. Like forget like the people will come. The apps are already there, and apps that are basically illumos apps will start using epoll. So, okay, fine. And again, you have to put it in the like B0 memset class of principles. It's like, okay, I'm just like passed it. Fine, epoll, have it, done. There's certain things I'm not gonna do. Jerry added exclusive IP stacks for LX-branded zones. I mean, the LX-branded zones were all shared stack. That was a matter of kind of catching them up, a lot of filth involved there. I added support for netlink.
How much of netlink did you put in?
So I put decent, I mean, you'll
Can you do IPsec policies?
No. So I did not. I did the netlink that was required for like IP adder work. I basically did RT netlink.
Okay.
I really tried to limit that. Now netlink, unlike everything else, actually, well not everything else, netlink is actually not a bad idea. Netlink is actually fun. It's actually, what netlink was trying to do was undo some of the ioctl mess, where just these ioctls with binary payloads, there's actually a protocol. I mean, it was a little overambitious, and I thought it was going to go over a little wire. Basically, it doesn't. But netlink creates this protocol to go communicate with the kernel about kind of arbitrary things.
They thought routing sockets and PF key were too individual, and they need to glom it all.
They need to glom it all together. It's netlink. It was a pain in the ass to do, but it's hard to begrudge the principles behind it. It actually seems somewhat reasonable. That I've restricted to the LX brand. That's all in lxnetlink.c. I've tried to implement it in such a way that if we needed to do it more generally, we could. So I don't know if we can do it or not. But that allows IP adder to work, which is that's like an important thing. Also, Robert added support for funkless native binaries. So you could run native binaries in the LX branded zone, but it was really horrific. We were appreciating that actually some of the value here, a big part of the value here, is that binaries like ZFS and Ptrace and dare I say PRStat and PStack and all MDB, all those friends, that you can just run those and they just work. So that actually does just work now, which is actually pretty sweet. I'll demo that in a second. Then we added native iNotify support. iNotify is another one of these things where we've just said, well, just use event ports. iNotify is definitely different from event ports, the file based on event ports. Similarly, so the way iNotify works is you say, I'm interested in this, what happens to this path. I want to be notified when an event happens. But instead of actually going through, well, obviously not epoll because it's not an event queuing mechanism, there's a separate event queuing mechanism. There's a device that you read from to read this stream of events that happened on these files that I'm interested in. Which is fine. That event queue can overflow. You have to be able to deal with that. So that's okay. That's fine. Where iNotify really went off the reservation is where if I'm looking at a directory, there are actions that I can see on my children, which makes sense. Like if I create a file in a directory, like that's an action on the directory. That's fine. But if I open a child file, that's an event on the parent. It's like, no, it's not. No, I'm sorry. Hi, hand in the back. That's not an event on the parent. What are you doing? So if you add a watch on a directory, foo, and foo/bar is opened or modified. So I opened foo/bar 5 years ago, and you come along and watch foo, and I do a write to foo/bar. You get a notification. It's like, why? What? That makes no sense. It makes zero sense. That you don't have any relationship necessarily with your. It's like, God, hard links must make this an absolute. Oh yes, hard link. Okay, yeah, right. Got it. Hard links do make this an absolute mess because with a hard link, it's like, well, which link did you write it through? And it's another example of where there's a lot of nuance and kind of implication. But we've fortunately, I've seen this a bunch in doing some of these things. Some extant facility got us almost all the way there. In this case, it's the file and event monitoring stuff. So I don't know how much you guys have to extend file and event monitoring for what you did on SMB2, but hopefully not too much. Hopefully we don't break one another. But the file and event monitoring, which was added for both SMB and FSV4 and event ports, I was able to just leverage that. And that facility actually was really properly designed. It was actually really well done. So I'm really pleased with that. That just worked. Then we've got initial 64-bit support, which Jerry has done the initial 64-bit push. This is super hard, and it's been a long grind to get 64-bit support, but we are successfully making 64-bit system calls right now, which is great. We need to get things fully working. So what's left to do? Well, every day you learn about something new, and yesterday it was V-sys call. If you know about V-sys call, you had one up on me. So it turns out Jerry finally was able to nail why we were seg faulting. Actually, the first reason we were seg faulting is because the agent LWP was instantiating itself on our. It's like, no, what are you doing here? I need you to leave, please. Don't, not now. We're trying to run Linux. Can you go away? But that was a nasty, nasty bug. The next reason is it was just like jumping off into space and dying. And Jerry's like, why is it jumping off into space? This makes no sense. Debug. And then he was like, oh, it's trying to jump off into space. Because space has this kind of cached system call layer. This thing called V-sys call was added to improve the performance of system calls. It's like, stop, please stop, please stop improving the performance of system calls. It's like, okay, so I understand like you're very excited about system calls. I get that, and you know that's a thing, and so all performance problems must be system call performance problems. But seriously stop, okay? Like, I got really good news for you. Microprocessor architects figured this out a really long time ago, and user kernel context switches are extremely fast. Please stop. But no amount of optimization is too much optimization for when we're talking about the system call path. And it's like, no, we can't just use fast traps. We actually have to execute code in user land. Well, it's like, now, okay, that's fine, but that should be, like, if you want to turn it into a library call, turn it into a library. Oh, right, we don't ship libc. I get it. Okay. Anyway, so they got this called V-system calls that, like, here's a page of magic that I pooped in your address space that allows you to just, like, make system calls that are actually virtual system calls, and then you can get things like time of day and so on. But, like, get time of day, but that actually how is that not now a security vulnerability? Because I now no longer get out of a privileged state. Oh, it turns out it is. So don't worry, we've got another thing that actually scans your address space, finds the system call, finds where the V-system calls are, and turns them into proper system call traps. And you're like, okay, am I the only one listening to you? I mean, can you hear what you're saying? And then, but no, the real problem with V-sys call is like it's only like one page or whatever. It's like, oh, we've run out of system calls. So it's like, no. So this whole thing is a terrible idea, and you must undo it. It's like, no. No, that's not what I was going to say at all. Mike, I know that's not what you're going to say at all. What we need is we need virtual dynamic SOs. So we're going to VDSOs. I don't know if you've seen this. There's this VDSO monstrosity.
That's what that is. Yeah,
that's what that is. It's like, get out of my address space. What are you doing? It's like, I'm solving a problem that I've created. It's like, why? Don't stop creating the problem. And this is a good example where like the VDSOs, I don't think we're going to have to support VDSOs. I think we're going to be able to sys that out. But V-sys calls are something we have to support. So Jerry's adding the V-sys call support. You're just like, okay, the V-sys call support. Anything else we're going to need for 64-bit, which they're presumably going to be other things like this. The good news is, and I say this with absolute confidence, we are converging faster than Linux is diverging. There is no doubt in my mind we will get this completely working. Given all the things that kind of structurally happened, the progress we've made so far, we are going to get there, no question. And given all the stuff that already works. So we're going to hit additional stuff for 64-bit, but we're just going to grind through it and do it. We need to do stack switching for Go. So, Go, so much rage. With Go, I don't know if anyone knows the inside of Go. You ever taken Go apart? So, you're like, oh, Go, it's great. It's like a modern language. Yes, it's a modern language built on a very antiquarian system. And basically, Plan 9 is inside of Go and is effectively responsible for the compilation of Go. And the only way to go in, so obviously I know all this viscerally because we had to port Go to illumos. And Go's like, well, there's this problem about this glibc dependency. And I'm like, yeah. So we directly encoded the system call table. It's like, no, come on. So a Go binary has the system call table in it. And there are two ways to view this. You can have an aneurysm and go into a spout of rage and despair about the humanity and move to Idaho and buy a mule. And I know someone who's doing that. You can do that. Like that's definitely like, that's a path. Like that's a viable path. I don't want to minimize that path. The other path you can say is like, okay, this actually helps because it helps to pour even more lucite over that system call boundary, right? I want that boundary to not change at all, ever, at this point. And the more things, it's like, no, please go directly encode the system call table. Go also, unfortunately, it knows they've got, what they've done with stacks is truly unholy. I think part of the reason they directly encode the system call table into Go is because Plan 9 does not actually implement the AMD 64 ABI. Because like that's hard, and like Plan 9's old, why would we do that? Like yeah, why would you do that? So in particular, it uses a stack-based calling convention, the Plan 9 compilers. And by Plan 9 compilers, I mean like 6C. Right, that makes sense, 6C. Right? I mean, if you take this apart like 6C, like what is that? Is that like a section of a man page? Like no, that's the command you run, 6C. Not to be confused with any of the other numeric commands that are, it's like, oh my God, what did this come out of AT&T? Oh, yes, this did come out of AT&T, got it. But so they, and I could be wrong in this, but I'm trying to understand why this is the case. And what it appears to be is that AMD 64 uses the stack to pass arguments. They don't actually use the register conventions, which means, well, you definitely can't call into a library, actually, because the library is written for a different microprocessor that you're not abiding by, and it's looking for arguments to pass in registers, not on the stack. So a lot of the work that we had to do for Go, for illumos, is to swizzle those arguments and to swizzle them off of the stack in the register so we can call into libc, because we have to call into libc. We cannot make the system call table directly into Go as a non-starter. And Aram H on Twitter is Aram. Oh, there you go. Thank you. Aram, I'm so sorry. Saint Aram, as we call him in illumos. Saint Aram did huge amounts of work to make this work, and we got a chance to work with him on Go. But we learned a lot about Go in the process. And another kind of artifact of Go is very aware of where its stacks end. LX brands bounce you into userland and do a lot of stuff potentially on your stack. And so it's not compatible with Go. So Go is one of the things that doesn't work right now. We're going to do stack switching. We are doing prototype stack switching, where when you come into a system call that needs to be bounced out of userland, we're going to switch our stack, so the LX brands are actually executing on their own stack. So they can't trash. So from Go's perspective, it's exactly like system call. So yeah, we need to go to that.
So the real question is, does system D work?
I know you've been waiting. And actually, System D is actually going to be much easier to get working than Go. So System D prides itself on binding directly to Linux interfaces. And I was reading one of the many
how does it do with all the enosis?
Flagrations. Exactly. Well, so it doesn't care. I mean, it literally is like run a new kernel. I mean, so it's like, I'm sorry, I'm in charge. You run a new kernel. And it's interesting to see how that's going to go. But if you look at one point, Leonard rattled off all the interfaces they're depending on as reasons why this would never be ported to FreeBSD as a point of pride, very distorted. And I looked at the interfaces and I'm like, oh God, here we go. And I'm like, wait a minute, check. Okay, KD bus, that's going to be a problem. But it's basically like, it's kind of, it'll be work, sure. And I'm sure I'll discover unholy things, and I'm sure, I should just pre-book my Surge Lightning talk for next year. Maybe I can book ahead for that. Because I'm sure it'll be just a fountain of bitterness, but I think we can get it to work. So you can go, multi-thread Ptrace support would be nice. So Ptrace is this antiquarian interface that we killed and replaced with /proc so debuggers could work properly. Unfortunately, there were some war orphans that discovered this ancient interface and built an entire system on it in Linux. So we need actually multi-thread Ptrace support is nasty, but we'll get that. And then, of course, we got a lot of using it and figuring out what breaks. So in terms of how do folks get involved, actually, let me go down. It's enough of the jibber jabber. Okay, so actually do it from here. So I'm on my, this is random SmartOS bits running recent SmartOS bits.
Bryan, can you increase the text size?
You bet. Yep. How's that? And what I'm going to do is just zlog in to my zone. So I'm now in an Ubuntu zone. And note one of the changes, we no longer say fake here. We say virtual. It's not fake. It's virtual. It's virtual. Like virtual basically being a euphemism for lies.
It's a virtual truth.
It's a virtual truth. It's a giant pack of lies. So, all right, so
You're in TC, this should be easy for you.
right, exactly. That's true. That's true. It's a convenient truth. I'm gonna let's see. I don't
Yeah,
get.
there you go.
So I've got no wget. So let's apt-get install wget. Run. Okay. Which wget? Now I've got the man pin. It's of course it's in the user bin. Fine.
You wget something random and pipe it through bash?
Yeah, I will. Let me do that right now. Actually, I am going to do that because that's what the kids do these days. We randomly download things on the internet and run them. That's what we do. So I'm going to let's go download node.js.org, and I'm going to go to the downloads here, and I'm going to find the binaries, 32-bit for now, obviously. That will certainly be changing. I'm going to copy that, and I'm going to Victor our temp node, and we're going to just wget. Yeah, thank you for the color. Fine.
Which version do you want to is this?
What's that?
Which version do you want to is this?
This is 14.4.
Yeah, didn't that show up in the email?
Yeah,
It's in your prompt.
Yeah.
Amazingly fast, it does not work.
Yeah, this actually is amazing. Well, this is Surge. So Surge has always prided itself on fast Wi-Fi.
Plus, it's only this room today, not the whole living.
So I'm going to download this. Actually, this is even faster than I was doing before, so we're ripping. There we go, and okay. And now I can, of course, because it's all GUI, do that. There was much rejoicing. So now I can do OS platform. Good. All right, now, of course, for the main event, so if I go over into native, so I'm in the same zone now, and I can, I think, do they have, yeah, of course right, they have feedrep. Actually, I think they actually called us out on that. Am I making that up? Did they actually show some respect? Notes, I think they did. There we go. All right. All is forgiven. So this implementation is fully compatible. Actually, it's not fully compatible because I know they don't pick up on the WChamp. But all right, let's. So I've got my node there. I've got my what? What are you calling yourself?
Node, I think it's by default now it's Node.js or Node-JS or something, not just Node.
Just suspend it, Control Z and do jobs -L, or you can do that too.
Sorry, process.py.
Ignore me.
You're logging? You're not logging. No. 1210. Where are you? Signal sender.
PR, can you do PRs?
Do you handle the PSA or the ARG movements on Linux?
Mhm.
Change their proc names
Yeah, they do.
correctly?
That actually should work. Although, actually, truth be told, I'm actually running my own bits on this. So if we do, sorry, where's the title? Is it process.title? Oh, it's title, right. Right. Sorry, excuse me. So I think that should work. Maybe not. Yeah, there we go. So yeah, I
I
do.
think somebody did, something clever before.
Yeah. So maybe something clever thought it was signal sender. Anyway. All right. Well, there's foo.
Good enough.
Yeah, good enough.
No, it's single sender again.
Or Joe, or no. That's not in the first place.
You could do
You
ER
grab
myself.
LF.
You could do 81210.
No, Linux.
You grab -LF, no, try that. No.
PIDO.
Angry. All right. Well, pgrep works. I'm not sure why. All right. I'll go figure out
Fully
what's that?
It's fully compatible.
Is it fully compatible?
You know that no Linux user really does pgrep. I've seen, you can pull it. It's
Stop.
PS minus the pythograph.
And then grep-v, your own PS.
Go pull your own and join class. You'll see the same thing. Don't throw your judgy eye at me.
Judgy eye is awesome. Actually, let's look at all the details here. I can actually run pargs. Actually, that's actually the real question. Oh. All right, so maybe that might be my bug. We're gonna pgrep might be defending you, but actually now I can run the pgrep. I can actually compare the pgrep side by side. But I can't actually.
Dot/pgrep.
No, that's
You, sir, did not kernel panic. Congratulations.
Yeah. Yeah, we still kernel panic. Again, I'm running. Let me emphasize, I'm running my own bits, and I will be debugging that. Very sure. My hackathon is spoken. Okay, let's. Oh, that's unfortunate. That's unfortunate. This is the danger. I could actually roll back and reboot. I might actually do that because it's worth demonstrating. But damn it. All right, so I should have actually tested this before coming down because I've clearly broken this in my wad. Which is good to know. I will be debugging this shortly. What's that?
What you doing in hackathon?
I know we're in the hackathon, and now let's just see if this is all. It's not all apps, so it does that. No. No. All right. Yeah, it is kind of all apps. All right. Well, we'll go figure that out. I have somehow broken that. Demo delayed. Not canceled. Only delayed. Only delayed. That does actually work, and we can certainly do it from the global. That would be interesting if we can't do it from the global either. That would mean that I've broken something even more fundamental. Yes, so certainly can do this. And let's just do so. Where are we? But again, this will be available in the now. If I do it off of foo, I should. Never mind. Stupid figure. Okay, going to that in, so 20,000 places, presumably hit enter. So this is actually, I instrumented that node binary, that Linux node binary, and that's everything that it's doing. We can actually go and, actually let's do this. Let's do, this is called entry, and let's actually aggregate, well, actually let's do this. Let's just aggregate on it. Let's get that aggregate function. Yeah. And this is, I hesitate to do this because this is going to make us slightly sad. You will see that's in node, so we actually do have something in the binary, which is nice. Before we actually lose our, that's actually live in JavaScript. That's actually not from the frame pointer. So you can see our UV over there. You can see, and we can actually now go and we can go implement. Actually, let's go instrument all of just the node. Let's do pid 81210 a.out. So again, these are all Linux symbols in the Linux binary. So this is all the kids like, wow, that's amazing, that just worked. It's like, no, it definitely did not just work. But it does work, except when every program cycles, which we're going to debug in just a moment. That's where we are. We are, I think that we're making very good progress. And I know I'm going to, but in terms of how folks can get involved, the first step is to get SmartOS running, for those of you who have or don't. We've actually got there's a 32-bit Ubuntu 14.04 image that you can use to create a zone via the ADM, and on that one, Ptrace should work, and MVB should work.
What's involved in taking a tarred up 32-bit Ubuntu box and converting that into an image for his own disk?
It's not that bad. It's just that it's not documented right now. It's definitely, I mean, that is what you're doing, basically laying down a tarball. It is highly possible, but it's not, what we are going to do, actually just jump ahead.
Rock placement and a couple of surgical drops?
Yeah, it's not, I mean, Jerry can kind of walk you through the details, but it's not, I mean, it's basically just tarring it up. I mean, there are some things that need to be cleaned up, but not many. And we are going to, once 64-bit is working, that's kind of what we've been waiting to get to. Once 64-bit is working, we are going to go much broader with this in terms of getting, because right up until this point, it hasn't really made sense to engage folks because we already know what's broken, and like, you know, MDB is like, well, you go to bug that. We're going to get to the point where things basically work, and we now need people to actually go beat on this and help us find other things that are broken. Yes?
Two things. One, you can actually use debootstrap for that. You don't even need to get a 12-ball. Or if you want, people are going to get to a 12-ball. But debootstrap basically does the equivalent of getting a Gen 2 12-ball extracting except for deadly Ubuntu or whatever.
Okay.
Dev distribution you want. And the other thing is,
That's great.
can you download the Gen 2 prefix bootstrap script and run it?
Can I?
How about you do it?
Yeah.
I don't have access to the system.
Yeah, I mean, that would actually be a good thing we should do.
You
We
said
break
you
up
were
here.
going to pipe some random shit to that.
Right, exactly.
This is exactly that.
Yeah, I know it'd be good to do that. I think we're at the point where, especially from an app perspective, we're looking for things to run and go verify they work.
It takes less than 1 minute if you do it right now.
Let's do a break up, so if that's all right. Because I do want to do it, but I also want to be mindful of the fact that I've kind of gone way over. And we can, that'd be good. I would like to do it though. In terms of configuring a VM, you need to set kernel version, we're citing 3.13.0, set the brand LX, that's in the VM ADM JSON payload. Again, we're going to document that much more thoroughly. If you do find something that's broken now, that's great. Create an issue on the illumos joint GitHub repo. And again, once 64-bit is working, we're going to be very actively seeking community engagement. So in terms of thank yous, huge thanks are actually due to the Brand Z team, Niels Newar and Russ Blaine, among others. The illumos community, again, David McKay, really have to credit the community. And to me, it's a great validation of kind of the model that we do have a kind of a community of self-selected, highly technical, borderline crazy people, which is great. As one of those people, it's a great community. And I love the fact that this work ultimately was inspired by him doing that work. Jerry, again, has just done terrific work. He's done the vast majority of the work, so it's been great to help him out. Robert did the ThumbQuest native binary support, but Robert would probably like me to emphasize that the bug that I have currently on my laptop is assuredly not his.
My demo was an Insight fault.
What's that?
I didn't say my demo was you.
It's assuredly me. Josh Kuo at Joint Stack Switching. DJ Hoffman was an intern who we cruelly put on Ptrace support for LX brands, which at the time this is kind of like taking a youngster on an inappropriate road trip. Exactly, that's kind of it. Be like, okay,
This Kool-Aid.
right, okay.
We need your emergency contact info. And hold my hand the whole time.
Yeah, I feel a little bit bad. I was kind of a DJ. I mean, this is a 21-year-old. Like, he's definitely not a kid, but I'm worried that it was too much too soon for him. So he saw a little too much suffering, I'm afraid. It's like, on the one hand, like, he wanted to travel, so we took him to a war zone. And now he has just seen, it's like, you gotta chase a travel. Like, when are you gonna chase a Fallujah again? It was great. It's like, I've seen horrific things that no one should see.
You showed him snuff films on the plane.
I showed him stuff that was on the way out to Fallujah. Exactly. Exactly. And then it's like a Clockwork Orange on the way back, Faces of Death in between. It's like, are you ruined yet? Are you destroyed? Are you no longer able to hold down a relationship or a job?
Human centipede.
That's Human Centipede, exactly. And at the end of the summer, I'm like, so good. How was the summer? It's like, oh, it was good. I mean, I was like, wow, I definitely learned a lot. I'm like, yeah, I was a little worried the Ptrace and Linux thing, it's a little, I mean, you're learning a lot about Ptrace, you're learning a lot about Linux, you're learning all the sub-optionalities of Ptrace, you're learning obviously a lot about illumos. I'm worried that it may have been a little too much. He's like, yeah, maybe. Like, I'm worried that you might resent me a little bit. He's like, A little. I'm like, okay, that's a lot. I got it. So anyway, hopefully he'll work for you someday and do great work, because he's clearly never going to work for us after what we have done. But he did great work on Ptrace. And Josh Wilson also did great work on the VM ADM support for Alex brands. So thanks to all those folks. And with that, I'll maybe take some quick questions and then break.
Yeah,
If there are any questions, so we can talk and the break. Yes.
So Solaris folks, just as this calls, also like to have like magical files and /sys that we interact with operating systems.
Yes.
Is that a thing that's?
So which magical files in /sys?
I was like a Docker page cache. We have this like C group thing that's kind of cool.
Okay, so sorry. Do you mean so when you say sys, do you mean like proxys?
No.
No, /sys.
/sys, okay.
It's sysfs.
So tell me what you want. So we've got a bunch of again, the point of principle is long past. So what can I do you for? So let me know, what you have got apps that need in /sys. And we will go. And is that stuff documented? If I do that, no. What's that?
Blogs.
Sysfs. There you go.
Check.
No.
That's not it.
That's not it.
Where's like UFS get documented, that section?
try.sys.com. Cross.
Is that it? Cisco. Is that
It's documented in code.
That's
I believe.
BSD. Is this good?
Man,
You can actually set variables in sysfs via syscto.com, which will ambiguous apply out.
Oh, sorry. Yeah, that's a good point.
Yeah. So again, whatever we need to do there.
Money's on the nightstand.
What's that?
Money's on the nightstand.
Yeah, actually. And then I actually just left the credit card there. So so just whatever. I left all my wire information. So I get it. It's fine. So it'd be good, Chris, just to get to details if there are specific things that we should go. I mean, obviously, like we're not going to implement everything, right? I mean, there are going to be lines, and what we're really the use case we're focused on, I would say, is, and it's convenient because of the enthusiasm that it has, is, we think that illumos with Alex brands is a great substrate for Docker. So what does a Docker user reasonably want is going to be one important way that we differentiate kind of what we do versus what we don't do. So it would be great to just, and then if it's in that category and we can do it, we'll just do it. Yes?
So
Yeah.
when you implement stuff like epoll and you download Joe random source code package and run autoconf, as we all do, and it goes through its list of, hey, what kind of polling mechanism should I choose? And epoll's in there.
Yeah, for me, in the native.
And normally on illumos today it would pick, I'm going to do
Event polls.
or events or whatever, but then it hits, epoll's first in my list, and I just found that. I'm going to use it. Should I be okay with it?
Yes, you should be okay with it because the application's okay with it.
No, I think that the issue is that question is what percentage of them actually have event port support there,
See how far.
and which ones actually don't.
I'm pretty sure that one of our products
if they
is gonna compile subtly differently now on that. It'll detect epoll.
Yeah, I think this is a case where basically then we need to. There's no good answer to how do you select between
minus disable epoll.
If it can use event, they say event ports or whatever, but it chooses epoll over that,
the application
should look at
the application's going to need to be updated the same way if it accidentally chose like dev poll or just old poll 2 instead of like something else.
I mean, to be totally honest, and this is where I guess, and the purists will obviously disagree, and they're about to, I would say if the application knows about event ports and knows about epoll and chooses to work in epoll, that's one less barrier you're going to have when the app doesn't work, or what have you, right? So I mean, I would say like epoll itself. I mean, it works.
As long as they don't do the batshit crazy thing.
Right, as long as they don't do the batshit crazy thing.
No, when app people do that discovery stuff in autoconf, they don't care about the order of checking for epoll or portfs because order doesn't matter now. Right, so that's the only.
Yeah, to me again, it's memset versus B0. It's like, well, I believe
Alright,
E0
so
represents
ePoll's a
that.
first-class citizen of an
ePoll's a first-class citizen, and that's been our. And no, there's a reason ePoll also has not been integrated yet into illumos because I think that's a fair kind of discussion to have. But from my, and I have to say this has already been validated. Salman had a good blog entry, and then Jake had an anecdote where it's like, yeah, we had software that was using ePoll, and they knew they had to use event ports, but we just didn't have time to do the conversion, and all of a sudden it just shows up and ePoll's working. So I think it behooves us as a community to adopt ePoll.
So I like this approach, but I do think that this is another case in point where, going back to what I was saying in my talk, where we're not SunOS anymore. Our API landscape is different.
One thing I should just clarify is that the problem that we're not SunOS anymore is a totally legit problem, and how do we identify ourselves is a totally legit. I actually think, to be honest with you, the illumos core stuff is going about it in exactly the right way. It's let's experiment with a bunch of different ideas and let's see let's try a bunch of different software and let's find because we do have a problem. And the problem is that some of us have ePoll and some of us don't. And we're not SunOS anymore. We're certainly not 5.11 anymore. And it's a problem we have to tackle. So, and there are probably a bunch of different ways to do it. So I think trust me, that was in the back of my mind during all that. It's we need to solve this problem. So we hopefully solve this problem in a way that hurts the least. But I think, the problem that we have to solve is that the capabilities of the system are changing, and you need to have a way of understanding programmatically what those capabilities are.
And that's really, it's not that even that the capabilities of the system are changing, but they're also diverging, right? So Oracle's off doing wherever Oracle's doing. Good luck to them. Whatever. We're in the community doing, pursuing other things, and at some level we also have, all of our local forks. Where for those of us that are building more appliances, like Contenta, it doesn't matter as much because they just build everything from source and forks and don't care about any of that shit. But for those of us who are building more general purpose systems, the smart data center stuff, OmniOS, this divergence and identifying the platform starts to become challenging, and we're going to start to. If you think about sort of the Linux space, Linux has this fragmentation problem as well. You have to have Red Hat, or you have to have Ubuntu, or Gentoo, or whatever, right? It's been tested. They have the problem worse now than we do, but my fear is that our APIs diverge. And especially if we don't solve the identification problem, it can become a crisis.
I totally agree. And I think we need to. It's not SunOS anymore, and we do. And
don't want 3 different illumos with 3 different APIs.
Yeah, that's right. And I think that we do. Well, I think that we want those to be able to clearly identify themselves. Because I think I do think that there is great value in. I think one of the major shifts, one of the major differences between Open Solaris and illumos, frankly, is that we've got a much healthier ecosystem of different ideas being experimented with, because we don't feel an obligation to only have one source of truth, which I actually think is extremely valuable. I think it's valuable to have OmniOS experimenting with things, SmartOS experimenting with things, illumos core experimenting with things, and then where the ideas are, let kind of each of us kind of suss these things out, and where the ideas are sound, let's get them pushed up. So I think that's very important, but it does highlight the need to be able to identify these systems. So no, I think it's a critical problem, and I'm glad that we're addressing it before things diverge too much more.
Brian.
Yes, Richard.
Which programs actually need ePoll? I would read that on Linux in general, we're supposed to be using either event or maybe using ePoll.
Oh, there's tons. There are a lot, yeah.
There's a lot of things you should do, and
you shouldn't be running a Linux offense. We passed the light of should a long time ago over here.
There's a ton of commercial products that map directly.
There's tons of shit.
Okay, so closed source stuff.
No, open source stuff too.
Commercial.
And commercial. Say HA proxy. That's a good example.
Yeah.
There's a case where it's we basically have different backends for everything.
So are these
ATS, Apache Traffic Server doesn't use libevent.
So these new alternatives you're asking about, these alternatives, are they newer?
No, they're abstraction layers. They're frameworks.
Because
and you write your application against it, link to it, And then this library is called against whatever the system happens to support.
What's it called? Lib-event?
No, yeah, this is stuff. It's nothing.
libev.
Yeah, libev, libevent.
Well, libev obviously works.
Yeah, I mean these all.
I mean, the reason ATS doesn't use that is because ATS doesn't fast.
I mean, to be honest with you, there's nothing, there's no hint in the ePOL man page that you should not program with this interface.
I mean, it's a public interface.
It's a public interface, public documented interface.
I wanted to ask you what your basis for that, or for Deadpool. What are you saying that it's really an inherently broken API, and why?
It is an inherently broken API.
It is an inherently broken API, but at that point of principle, it's
Multi-threaded, he gave you the race condition.
Yeah, I mean, and actually, there's a very convenient fact at the end of this that has what happens if you register the same files with an equal instance twice? You will probably get exist.
Probably.
It's like, did you just say probably? I mean, it actually describes all of the. So I mean, it's actually pretty candid about all the limitations, and they actually tried to resolve some of these things.
So are people trying to use this directly with a multi-threaded program, or
all the time?
Yeah, and they're just suffering, and they're doing all the things that are necessary to get it to work, and it's just awful.
I'm curious because I worked on probably one of the only consumers of DevPol that did it in a large multi-threaded program.
We did.
There was technically
We have a big program that used to use DevPol. He supports now, but the commercial.
And it did two tricks basically. It has a pipe that just does pipe in user space and hooks one end of that pipe into the
right
to do wake ups. And then there's one thread that sits there in Deadpool.
And
then that hands it out onto a queue.
Yep. And that's what you have to go.
That works fine, but it is kind of a tricky programming model. And
that doesn't work fine.
You're answering your question.
High TCP accept volume. So if you're going to be accepting 150,000 speed connections a second, you actually have to accept across multiple threads, so you need to be pulling from DevPol across multiple threads. It's the whole single-threaded, event-driven program is awesome when we had 100 megabit networks and giggy networks, but then after it went, we have eventer loops, and we have 2 eventer loops per core at 32 cores, and shit's going off the rails. It's so in ePOL.
Yeah, I would agree that it didn't. What I saw wouldn't have scaled that far.
Right.
Yeah, they worked fine. But the single reader did at least avoid the locking problem you're talking about. That's what I was curious about.
It's not a locking problem. You can miss notifications very rarely, but you get spurious notifications that are unnecessary. So it's a pretty significant performance problem.
And again, it's nothing. It's resolvable. It just requires a lot of application complexity, which I mean.
The one thing I remember we would wish for, we wish there was a one-shot, because you really don't want, once you dispatch something out to a request.
Yeah, so they actually added a one-shot. They added an ET one-shot, which was has its own then problems. There is one-shot support, but then that becomes unusable for other reasons. And then, actually, our man page goes into all of it. I've tried to not develop PTSD by dumping it all into man pages. So man pages and code comments generally have all of my perspectives on why these things are.
One of the biggest problems with using libevent and libuv is that they usually interleave more than just file descriptors in there. There's timer callbacks and things like that.
It's your whole event loop usually, right?
Yeah, which is a whole.
Libuv is your whole loop.
Yeah, it's the whole picture, and then there are some really bad they don't use lock-free data structures or wait-free data structures where they didn't need to make a choice. So when you're multi-threaded and you're doing events that fire, it's hard to give eventer core locality to them. There's a lot of really hard problems that kind of just punted on because most people run one event loop, which doesn't scale.
All right. A long way of saying people definitely code equal directly for certain.
There are lots of financial systems that are very latency sensitive that consume the fuck out of me. I'm telling you, when we saw ePOL, it was where are all those assholes? Bring them here. Come in. Because, we didn't think AliExpress was going to be. Yeah. I wasn't going to. There was no way.
Right.
We couldn't do it. And then when that came, it was we can lie now.
Exactly.
Come here.
So that was the answer. I didn't realize people were actually using multiple threads actually going into ePOL.
Yeah. Trying to.
The standard
From my previous understanding, that would have been a completely wrong model. That shouldn't work at all.
Yeah.
So I want to discuss something. I actually wrote a few years ago a database in production at the moment, and it uses ePOL directly. At the time, I said to myself, I should write this to use what we need. but at the time I was rescuing this startup, my alma mater, from Windows and .NET.
We're all sinners. Don't worry, it's fine. It'll work. That's the point.
I think there should be never any problem with using
the system.
Using the system, right?
Exactly.
I mean, if you had KQ, that's honestly, there's a lot of regrets about the event port system as well.
Yes, we could rewrite history. We should have done KQ.
It should have taken KQ.
Should have taken
KQ.
No question.
The only one that was sufficiently different that merited its own different design was completion ports. I have completion ports on Windows, which are much harder to code to, but arguably much better from a performance management standpoint. Because it's not blocking, it's not unblocking, it's actually asynchronous. When I told you to go right, it doesn't say this. It says I'll get back to you when that's done.
I love these calls that do that.
All right, thank you very much. And I got t-shirts for mine and Agnes, and then I got t-shirts. So, come see you for t-shirts. Thank you very much, everybody.